Alright, hello, this is Kevin the TA, and I'll just do a quick intro to gases, or recap I guess, since most of this should be reviewed for you guys. So let's just go over the properties and the applications of those properties in real life. So, as you know, air is a gas. It's pretty cool. I like to inhale air quite frequently. And then if you do heat air, it causes it to rise, which is how balloons rise. It's pretty great. And then also, as you can see here, you have a test dummy crashing into an airbag. So an airbag is actually inflated with sodium azide. And so the sodium azide is ignited as the car is sensing that you're going to crash, which is what causes it to actually inflate so fast. And so let's just talk about what can become a gas, since technically it is everything can become a gas, but it is way easier for some elements than others to become one. So all of the noble gases, hydrogen, helium, all the way down row A, they will be a gas at room temperature, 25 degrees Celsius or 77 degrees Fahrenheit, and 1 atmosphere pressure. Then also one thing to note is that generally non-metals have a much lower boiling point than metals do. So just to repeat my point, metals can be a gas. So for example, nickel here, it can be a gas. It'll just take a lot more energy to make it into its gaseous form than it will take for oxygen, for example. So here are just some more examples of substances that are gases at room temperature, basically normal pressure. And so as you can see, noble gases generally don't bond to themselves and they're just on their lonesome. Then chlorine, fluorine, oxygen, all those, they're bonded to themselves as they're more stable that way. And then something to note about the compounds or gases that can be compounds that can be gases is the fact that all, if not most of them, are covalently bonded. Sodium azide is an exception, but for the most part, gases will be covalent or include all nonmetals. So the physical characteristics of gases we should know is that they assume the volume and shape of their containers similar to liquids. They are the most compressible state of matter, which basically just means that we can decrease the area of which a gas takes up a lot easier than we can with liquids or solids. And then also, gases will mix evenly a lot easier than, for example, a liquid will if they're in the same container. So a perfect example of this is actually our atmosphere. So if you take an air sample from, for example, California and Florida, they're at the same elevation roughly. So that means that the air should be the same. Of course, it probably will not be due to pollution, but gases do like being very even. So if you release a gas in a room, it will disperse so it's evenly represented in every corner of the room. And then also something to note is that gases, have much lower densities than liquids and solids, which is partially why they're so easily compressible. And then we can talk about the properties of gases. So helium, it is much less dense than air, which is what causes a balloon to float. And what causes a hot air balloon to float isn't that the air inside of a balloon is less dense, but since it's hotter, hot air rises and cold air falls to the ground, which is why balloons take off in the morning when the air is cold, so that the hot air heated up by the torch of a hot air balloon can actually push it up into the sky. And so we've been talking about the room pressure, or 1 atm of force. And so what does that actually mean? So pressure is force over an area, And so one way we can show this is that 1 Pascal of force is 1 Newton of force per meter squared. So in one atmosphere, or in a normal pressure in Florida, for example, you would have 101,325 newtons of force in a meter squared area. It's kind of hard to visualize this, but that is the conversion, so just remember this. And then one funky unit is millimeters of mercury. And so the way you use this unit is, if you have a barometer here, this gray stuff is all mercury. And if you raise or lower the pressure, the mercury will go with it. So as you can see, if we had mercury starting at this level and then raised up when we added gas into a container, if it rose 76 centimeters, that is equal to 760 millimeters. And as you can see here, 760 millimeters of mercury is equal to 1 atmosphere. So if we added gas and the mercury rose 76 centimeters, we have 1 atmosphere of gas added. And then that is also equivalent to 760 torr. And then the last thing to show off, I guess, is how we have different pressures. So with Colorado, we are different than Florida and California, seeing as we are the mile-high city. And so since we are a mile above them, what this entails is that we have less air actually pushing down on us. So what you can imagine is that if you do go to Florida, you essentially have 1 more mile of air pushing down on you, which is what makes it have more pressure down there. Yeah, that is all really as review for gases. Hopefully this was an easy video. Yeah, have a good day.